All right, imagine you're cooking a huge meal. You need veggies from one store, spices from another one clear across town, and your main protein from some specialty shop that's even farther away. How in the world do you get all of that back to your kitchen efficiently? Well, that's pretty much the exact puzzle that distributed databases are solving every single second of every day. I mean, really think about it. When you search for something online, book a flight, or even just scroll through your social feed, you're sending out a little request, a query that has to grab bits of information from computers all over the planet. How does it happen so fast? That's exactly what we're going to break down. So, the first piece of this whole puzzle isn't about if we can get the data. We know we can. The real trick, the real question, is how we do it in a way that's fast, cheap, and doesn't waste resources. It's this massive logistical puzzle on a global scale. At its heart, the idea is actually pretty simple. Unlike a traditional database that lives on one big, powerful computer, a distributed system spreads the information out. It's scattered across a bunch of separate computers or sites, and they're all connected by a network. That network could be anything, really, a super fast local connection or just the regular old internet. Okay, now let's get to the real core of the problem. If our data is spread out all over the place, we have to move it to answer any questions. And just like shipping a package, that movement has a cost. This is the single biggest thing that makes distributed query processing such a unique challenge. I mean, today's computers are ridiculously fast. They can crunch numbers and process data in the blink of an eye once they have it. The real bottleneck, the most expensive part of this whole operation, is the time and energy it takes to send that data from one place to another over the network. And this quote just sums it up perfectly. Every single clever strategy we're about to talk about, it's all designed to minimize this one thing, that communication cost. And the cost? It boils down to a super simple formula. It's some constant, C, the price per byte, multiplied by the size, which is just how many bytes you're trying to send. So the goal's always the same. Make the amount of data you're shipping around as small as humanly possible. So the first big question you have to ask is, where should all this data meet up? Let's say our query needs info from Site 1 and Site 2. We've got a few basic ways we could handle this. Okay, so we've got 3 basic moves. Option 1, ship everything from Site 2 over to Site 1 and do all the work there. Option 2, you guessed it, do the exact opposite and ship everything from Site 1 to Site 2. Or Option 3, send both chunks of data to a totally neutral third location, Site 3, and do the processing there. So how do you pick the right one? Well, it comes down to a few key things. First, the size of the data. If the file at Site 2 is tiny and the one at Site 1 is massive, it makes a ton of sense to just send the small file. You also have to think about the network itself. How fast is the connection? And finally, where does the user actually need to see the final answer? Now, those 3 strategies, they work, but they can be incredibly inefficient. It's kind of like shipping an entire grocery store to your house just because you needed a carton of milk. There has to be a better way, right? And thankfully, there is. This question right here is the big breakthrough. Instead of shipping that whole grocery store, what if we could first send a very specific shopping list? What if we could trim all the fat from our data before it ever even touches that expensive network? And this brings us to the hero of our story, the semi-join. It's this really clever operation that does exactly that. So before sending a massive table of customer data from Site 1 to Site 2 can first send a tiny list of just the customer IDs it actually cares about. Site 1 then uses that list to filter its giant table, keeping only the rows, or tuples as they're called, that matter. And then it sends that much smaller file back. By shrinking the size of the data before we send it, we directly and dramatically slash the transfer cost. We're attacking the size part of our cost formula. It's just an incredibly elegant and effective solution. It's that simple. The difference is just night and day. On one hand, you have the brute force way, sending these huge unfiltered files, which leads to super high costs and slow speeds. And on the other hand, you use a semi-join. You send only the necessary bits of information and your costs just plummet while your speed skyrockets. So why does any of this matter to you? Well, because this is the kind of invisible magic that's happening behind the curtain all the time. When you get a search result in less than a second from a company with servers all over the globe, it's not just because their computers are fast. It's because of these smart, cost-saving operations like the semi-join that make the impossible feel totally instantaneous. And that kind of leaves us with a final thought. The semi-join is just one amazing example of an elegant solution to a really complex problem. So the next time you use your phone, just think about the incredible engineering and all the clever shortcuts working together just to make it all feel simple. What other optimizations are hiding right there in plain sight?